Today we are going to be adding and subtracting rational expressions. We're going to follow the following steps. Step 1. Factor the denominators if possible. Step 2. Multiply in what is missing from the LCD, also known as the least common denominator. Step 3. Combine fractions into one fraction and simplify the numerator using the distributive properties and combining like terms. Step 4. Make sure the final fraction is reduced. You're going to factor your numerators, factor your denominators, and make sure nothing cancels. Let's take a look at example 1. You'll notice that these are not rational expressions. These are just fractions that we're going to add together. I'm going to work it out, and then I'm going to show you how it's related to the steps that we are going to be using for rational expressions. So, if I have 1/6 plus 4/9, I know that if I'm going to add two fractions, I have to have a common denominator. This is also known as the least common denominator. If I know my denominators are 6 and 9, I know my least common denominator would be an 18. So I know that I have to get both fractions to have a denominator of 18. So I would look at my first fraction so I can see what I can multiply in. Right now my denominator is a 6. I need it to be an 18. So I know I need to multiply in a 3 in my numerator and in my denominator. Then I look at my second fraction. It's a 4/9, and I know that I need an 18. So I have to multiply in a 2 in my numerator and in my denominator. Once I do that, I can see that I've changed my fractions into 3/18 plus 8/18. Once I have a common denominator, I can actually combine these into one fraction, and I can say that I have 3 plus 8, and then I write my denominator one time. So I have 3 plus 8 all over 18. Then I can combine my like terms. 3 plus 8 gives me 11, and I have 11/18. And then I check to see if I can reduce any more. Once I realize that I can't, this is my answer. Now, what I'm going to do is I'm going to show you that this is related to the steps we did before. My first step said to factor the denominators if possible, and that's what we did not do. So I'm going to look back at my example, and we're going to actually do that first. According to my steps for adding and subtracting rational expressions, the first thing that we should have done would be to factor my denominators. So I can say, okay, my 6 can actually be broken apart into a 2 and a 3. So I can rewrite this first fraction as 1 over 2 times 3. I would drop my plus sign, and then I would factor my denominator for 4/9. I would end up with 4 over 3 times 3. Well, my least common denominator has to contain all of the factors of our denominator. So my least common denominator would have to have a 2 because I have a 2 in my denominator. It would have to have 1 3 because each of my fractions has 1 3. And it would also have to contain the last 3 because it is also a factor of my denominator. This is how we get the 18, because 2 times 3 gives you 6, 6 times 3 gives you the 18. This is how the least common denominator was found. Now, whenever I look at this, I would actually multiply in the factors that are missing. If my factors of my least common denominator are 2 times 3 times 3, I would look at my first fraction. Well, I have the 2 times the 3, but I'm missing the 3. So I would multiply in a 3 in my numerator and a 3 in my denominator. Then I would look at my second fraction. I have 4 over 3 times 3. Well, it's missing the 2. So I would multiply in a 2 in the numerator, and I would multiply in a 2 in the denominator. This would change my fraction. So I would have 3 over 2 times 3 is 6 times 3 is 18, plus 4 times 2 is 8 all over 3 times 3 is 9 times 2 is 18. Then we would combine our fractions into one fraction so we could simplify our numerators using the distributive properties or combining like terms. So I would end up with 3 plus 8 all over 18. And then I would simplify that. So 3 plus 8 gives me 11. So I would end up with 11/18. Now you'll notice that we were able to get the same answer that we got before. Both answers are correct, but this second way that we did it is going to be how we will be working out rational expressions. Let's take a look at example 2. On example 2, whenever we do this one, we need to figure out what our least common denominator is. Sometimes it's hard for people to see whenever they are written like this, so we want to go ahead and factor our denominators just like we did before. If I were to write my prime factorization for 1 over 2x squared, I would end up with 1 over 2 times x. I would have a plus sign, and then I would write the prime factorization for my 4x. So I would have 5 divided by 2 times x. Then I would figure out what my least common denominator was. My least common denominator must contain every single factor that is in the denominator. My first factor is a 2. I have a 2 in my first fraction and a 2 in my second fraction, so I must have a 2 in my least common denominator. My denominator contains an x in my first fraction and an x in my second fraction, so my least common denominator must contain an x. My first fraction contains an x, but my second fraction doesn't contain that same x, but I have to include it in as part of my least common denominator. My second fraction contains a 2 that is not in my first fraction, so my least common denominator must contain my 2. Now I'm going to multiply in what's missing. Well, in my first fraction, I have a 2 times an x times an x. If I look at my least common denominator, I can see that I have a 2 missing. So I'm going to multiply in a 2 in my numerator and in my denominator. Then I look at my second fraction. My denominator is 2 times x. Whenever I look at all of those factors, I can see that there is an x missing that I need because it's in the least common denominator. So I'm going to multiply in an x in my numerator and an x in my denominator. Now I'm going to go ahead and simplify my numerators. So 1 times 2 gives me 2 over, and then I have 2 times x times 2. That gives me a 4x squared plus 5 times x gives me a 5x all over 2 times x gives me a 4x squared. Once we have a common denominator, we're going to go ahead and combine our fractions into one. So I have 2 plus 5x all over, and we write our 4x squared one time, because remember, whenever we combine our fractions, we only write our denominator once. Then we look to see, can we combine like terms? Well, 2 plus 5x cannot be simplified, so this is my answer. Let's take a look at example 3. On example 3, we have an n over an n minus 2 minus 3n minus 1 all over an n minus 2. So the first step that I'm going to do is I'm going to factor my denominators. Well, if I look at my first fraction, I can see that my denominator is n minus 2. This is unfactorable. It's already prime. It's a linear factor. So I'm going to leave it alone. Then I look at my second fraction, and I'm also going to leave that one alone because n minus 2 is already prime. So whenever I look at this, I'm going to say, okay, my least common denominator is an n minus a 2. Well, I already have a common denominator, so I don't have to multiply anything in, and I can go ahead and combine my fractions as one. Now, you have to be careful whenever there is a subtraction sign. Anytime there is a subtraction sign, your second numerator must have parentheses around it in order for you to distribute the -1 that is in front of that parentheses, because there is an imaginary -1 that must be distributed to the second numerator. So I would end up with n minus parentheses 3n minus 1 close parentheses all over n minus 2. And I see this imaginary -1 that's in front of my parentheses. So remember, we use the distributive property in combining like terms to simplify our numerator. I have n, -1 times 3n gives me a -3n. -1 times a -1 gives me a +1 all over n minus 2. Then I want to go ahead and see what I can combine in my numerator. Well, I have a 1n minus a 3n. Well, that gives me a negative 2n plus 1 all over an n minus 2. So this right here is what I've gotten so far. Now I have simplified my numerator to negative 2n plus 1. Now I'm going to look to see if there's anything that I can factor from my numerator. Well, negative 2n plus 1 is already a linear factor. The only thing that I could do if I wanted to would be to factor out a negative 1. I could change this into negative parentheses 2n minus 1 close parentheses all over n minus 2. Both of these answers are correct. One just has the negative factored out. But these are the exact same answers. Let's take a look at example number 4. We have 5 over x plus 3 plus 2 over x minus 1. The first thing I do is I look to see if I can factor my denominators. X plus 3 is already a linear factor, so I'm going to leave it alone. X minus 1 is already a linear factor, so I'm going to leave it alone. I'm going to write my least common denominator. My least common denominator must contain all the factors of my denominator. In my first fraction, I have a denominator of x plus 3. So my least common denominator must contain x plus 3. Notice I have it written in parentheses. Now we look at our second fraction. It has a factor of x minus 1. X minus 1 must be contained in my least common denominator. I have to represent all the factors of my denominators. Now I can multiply in what's missing. Well, looking at my first fraction, I only have the x plus 3, so I know that I am missing the x minus 1. So I will multiply that in my numerator and my denominator. Then I look at my second fraction and I can see my factor of x minus 1. I am missing the x plus 3. So I'm going to multiply in an x plus 3 in my numerator and in my denominator. Once I've multiplied in what's missing, I can go ahead and combine my fractions into 1. So I end up with 5 parentheses x minus 1 close parentheses plus 2 parentheses x plus 3 close parentheses all over my least common denominator, which was x plus 3 and x minus 1. Now I can use the distributive property and combining like terms to simplify my numerator. 5 times x gives me a 5x. 5 times a negative 1 gives me a negative 5. 2 times x gives me a positive 2x. 2 times 3 gives me a positive 6. All divided by, leave your denominator alone. Whenever it's in its factored form, we don't want to mess with it. So we have x plus 3, x minus 1. Now I'm going to combine like terms. Well, I have a 5x and I have a positive 2x. I get 7x. I have a negative 5 and I have a positive 6. So I get plus 1 all over x plus 3, x minus 1. I look at my numerator to see if I can factor it. 7x plus 1 is unfactorable, so we leave it how it is. And this is my answer. Thanks for watching the first part of adding and subtracting rational expressions.